Hey everyone, it's Mrs. Brimlow, and today we're going to talk about how to write repeating decimals as fractions. So, from our first lesson, we know that repeating decimals are rational numbers. To be a rational number, it means it can be written as a fraction. So, we know that it can be written as a fraction, but we're not sure how to do that. So, that's what we're going to start studying today. So, if you have a copy available, you should have the notes out to copy as you go through the video, or watch the video and you can get a copy later. Okay, so it should look like this. So, if we start with the solve and discuss it, I want you to pause this video and take a minute to try and do this, and then come back to go over it. Okay. So when we're writing decimals as fractions, we write them as we read them. So we see what place value did the decimal end in, okay, and we write it. So this would be 5/10, which I can simplify to 1/2. Okay. 27 hundredths. And then this is either 163 out of 100 or 1 in 63 hundredths because it ends in the hundredths place. Now, once again, we know from the bar notation this is a repeating decimal, but what we don't know is how do we write this as a fraction? Because there's no end to it. We don't know what place value this ends in to write it as a fraction. So that's what we're going to learn how to do today. Okay, so we're going to skip that for now and come back to it. So we're going to start with example 1 together. Okay, and before we do that, we're going to watch a quick video to help us set the stage for this problem. So let's go ahead and watch.
How can you write repeating decimals as fractions? Think about this question during the lesson. The Sluggers baseball team ended the season with the highest win percentage in their division. What is the Sluggers winning percentage written as a fraction? As you may already know, sports statistics are often rounded to make them easier to compare. Here, the Sluggers percentage is 0.555 repeating, or 0.5 repeating, rounded to the thousandth place. It rounds up to 556 thousandths.
All right, so I didn't know this as I don't know much about sports, but I do understand they had to round this in order to compare. You have to have the same place values to compare these numbers. So let's come to our notes. So what do we know? So we know that for the Sluggers, we know that they had 0.556. That's what they rounded to. And we know that this is really 555 repeating, but they once again had to round it, or 0.5 repeating. Okay. I apologize for the pause. I just had to situate my materials. So, coming back to the problem, this is what we know so far about the Sluggers. So, just as a reminder, fractions are a ratio of two integers. When I say integers, I mean positive or negative whole numbers. So that's what I'm trying to write. I'm trying to write a ratio of their wins in fraction form as a ratio. Okay. All right. So we're actually going to use some algebra and solving equations. Somebody a long, long time ago, when they had a lot more time on their hands and a lot of people were discovering these different math theories, science theories, and so on, found a way to prove and show how to write repeating decimals as fractions. So in order to do that, we're going to start by taking a variable. I always like to use x. You can use what you're comfortable with, and assigning it to your original number. Okay. So in order to write this as a fraction, we need to have two integers, meaning there shouldn't be any decimals in our fraction. So I need to somehow eliminate this decimal to get it as a fraction. So in order to do that, what we're going to do is we want to move this decimal point, okay? So you have one set of the pattern in front of the decimal as a whole number. So we only need to move it once because there's only one number repeating in this pattern. Now we can't just move decimals. We have to use our mathematics to do that. So in order to do that, I'm going to multiply this entire equation by 10. So we use tens and what we call powers of tens because that's what allows us to move our decimal. When we multiply or divide by 10, 100, 1,000, so on and so forth, that allows us to move that decimal place. So when I multiply 10 by everything, I get 10x equals 5 because it moves over once. And then that 5 still continues on forever. That is unaffected. Okay. So we're halfway there. So now I still need to get rid of this decimal in order to get a fraction. So what I'm going to do is I'm going to subtract that original equation we wrote. Okay. Now, even though these decimals go on and on and on forever, because they're the exact same thing, when you subtract something from itself, it leaves you with nothing. So now all I'm left with is 5 minus 0, which is 5. And then on this side, I'm doing 10x minus x, or 1x, which gives me 9x. Okay. And then equals. And now we're just going to finish solving an equation like we would. So I'm going to divide by 9 on both sides. But I'm not really going to go through and divide because then it's just going to bring me back to the beginning with my decimal. And we want a fraction or a ratio. So I'm going to just leave it as 5 over 9. So that means 0.5 repeating, or the slugger's percentage, is 5 over 9. Okay. All right, we're going to use this process for our next one. So we're going to write 0.7 repeating as a fraction. Okay. So once again, we start with a let statement. We're going to assign a variable to our original number. Now, once again, I need to move the decimal point, however number of spaces, to get one set of the pattern in front of that decimal. So I only have one number repeating, so I only need to multiply by 10. So when I do that, I get 10x equals 7.7 repeating because I move it over once, giving me the whole number 7, and then that pattern continues to repeat. Okay. And then I subtract the original equation to get rid of that decimal because they're exactly the same. So 7 minus 0 is 7, and then over here I'm left with 9x. Now we know from solving equations we do the opposite of what we see. So we're going to go ahead and divide by 9 on both sides, but leave it as a fraction. So it's, 0.7 repeating is the same as 7 ninths. Okay. I'd like to do one more example with you before you practice today. So if you could flip to the back of your notes, we're going to finish with this example 3. So we're going to write 0.23 as a fraction. Now you're going to notice that for this decimal, there's 2 digits repeating. So we're going to follow the same steps. There's only going to be one thing different. So we're still going to start by saying let x equal 0.23, repeating. Now, in the last 2 examples, I needed to move the decimal point one time in order to get one set of the pattern in front of the decimal. However, this time I have 2 numbers, meaning I've got to move that decimal point twice. So I have to think what number is going to allow me to move that decimal point twice. So going back to what I said before, we use what we call base 10 or powers of 10. So that means 10, 100, 1,000. So we keep adding zeros to the end. So in order to move it twice, or if you think about it, it's in the hundredths place where that pattern ends, that's what I'm going to multiply by. So this time, the only difference is I'm going to multiply the equation by 100 to move the decimal point. So I get 100 times x. The 100 allows me to move it twice, so I have one set of the pattern in front of the decimal, okay? And then that pattern keeps repeating forever. And once again, we need to get rid of that decimal point. So we're going to subtract the original equation. Those decimals cancel out, leaving me with 23 on this side when I subtract. Now on this side, instead of being 9x, it's going to be 99x. Okay. Then we're going to divide by 99, and we find that x is equal to 23 over 99. Okay. So Make sure you're paying attention to the number of digits repeating. Make sure you're showing your work so that way you can go back and see where you may have missed a step. Hopefully, you're starting to see a pattern, which we'll discuss in our next lesson. But for right now, go ahead and practice this either with whatever's in Canvas or whatever the teacher has for you. And we will chat soon. Thanks.